Thanks for joining our virtual open house for 2020. We're going to spend a few minutes. You're going to show a little bit of a short on what we did in 2019 and what we're about to do in 2020. We've made an enormous amount of progress cleaning up your water. You're going to be excited about what you hear before we talk to you live in just a couple of minutes. Thank you. Okay, I apologize. Some technical difficulties. What a surprise. Zoom, first time around. I'm going to introduce Mike Egan. He's got a few words to say, and then we're going to get started. Thanks very much for your patience. Some people were having a hard time joining, and we were learning how to do this ourselves. Mike.
Welcome. Hey, thank you, Z. My name is Mike Egan. I have the privilege to be the president of the board of the Barnstable Clean Water Coalition. Z. Crocker and I 3.5 years ago took over some of the leadership of then the 3 Bays and now the Barnstable Clean Water Coalition. And before we deliver all this great content today, I just wanted to say thank you to all of our staff, the members who are on the call today, our board, and to all our supporters out there that have made all the work that we have achieved possible. In Osterville, about a month ago, we had a boil water order. It only lasted 3 days, and the comm department, the clean water, the public water department at the town did a pretty good job cleaning it out. Turned out not to be a big problem. But for the 3 days, it really made us here in town appreciative of the privilege we have of having clean water available on tap 24 hours a day. And it reminded me of what we're fighting for. What we're fighting for is I would say the innocence or the peace of mind that we can get a glass of clean water, we can go fishing, we can eat a clam, we can jump in the pond, we can go swimming in the ocean, and at any time we want. And if we don't change a little bit of the way we behave and the way we use the resource, those privileges will be distant memories. The good news is the challenge that we have before us is winnable. Through the work that we at the 3 Bays, Barnstable Clean Water Coalition, are doing, and that Z is leading us, it's there's light at the end of the tunnel. So with that, I'd like to introduce Z. Crocker, our chief executive and leader of a lot of the good things. Z, help us out.
Thanks, Mike. Thanks, everybody. So we're going to go do a couple of things today. So we're going to run through a little bit of a slide deck. We've got a couple of videos that I think you're going to really enjoy. Sorry, the tape loop went on a little bit, but we have a couple of great videos talking about new septic system technology, as well as some important work that we're doing in the pond area so you can understand more about ponds. All water is connected on Cape Cod. We know that. You've got a single source aquifer. You've got freshwater ponds and lakes. You've got the saltwater estuaries. We're all connected. We're all in this together, and that's what we've got to work toward fixing. We'll go through a little bit on the conditions, how we got here, just for a minute, and we'll talk about source reduction and how important that is, and we'll talk about existing conditions and how we can fix those. And then we've got a special guest speaker we're really excited about, Chris Kilian from Conservation Law Foundation, who's going to update us about what we believe, a very, very important Supreme Court decision that's going to help us here on Cape Cod and probably around the country. So the history, how did we get here? We know this intuitively, but an image really tells the story. Look at the kind of development that we've seen over the last 30, 40, 50 years, and we know what happened. This is what happens when you get this kind of development. We overload our sandy soil, and that's really what happened, and that's how we've gotten to this point today. A lot of people think there's a lot of septic system, a lot of municipal treatment already on Cape Cod. Well, I mean, take a look at this. The black, this is all the municipal treatment we have on Cape Cod right now. Not very much, not nearly enough. And one of the things that everybody should know is that we're totally for municipal treatment. We need to expand, we need to work, we need to spend money on expanding municipal treatment. It's absolutely critical. If we don't do that, if we're not able to do that, we're not going to be able to move forward and solve the problem. So we are all in and all supportive of that work. That's critical for everybody to know. Take a look at the next 30 years in the town of Barnstable. This is the plan, a 30-year plan for a rollout of expanded municipal treatment in the town. This is estimated currently to cost about $1.1 billion for 9,800 parcels. Just on construction alone, that's about $87,000 a parcel. So there's 3 phases, as you can kind of see here. The red is the first phase. A lot of it goes down the spine of the middle of this town, Route 28, phase 2 and phase 3, all looking to solve problems related to nitrogen and the Massachusetts Estuaries Project work, which targeted something called TMDLs, total maximum daily loads. We're overloading our estuaries, even as we overload our ponds and lakes and streams, but those aren't regulated the same way. So we're looking at this work, this effort, and I think one of the things I want you to look at on the screen is to say, well, what about the white space? Gray is everybody that's got existing treatment. Red would be phase 1. But the white, and nobody gets treatment ever in this plan. And so that's why we started to work very, very diligently to look at alternative septic system technology, which is going to be so critical for areas that simply aren't going to see municipal treatment because they're too far away, it's too expensive. It just doesn't make a sense for a variety of reasons. And so that's what we're working toward today, is to figure out how to do that. And we're excited because there's some really great developments going on. Now, step back. Almost 1,000 lakes and ponds on Cape Cod, 11,000 acres. We've started to do work on one particular pond called Chubel Pond, a troubled pond, a small pond, fed by groundwater, fed by, unfortunately, a lot of septic systems that really don't do their job in terms of removing nutrients, and that's what we're trying to correct and fix. And if you take a look at this image a little harder, hopefully on your screen you can see it, you'll see that there's really only one connected, a few sub-aquifers. All our water is connected here on Cape Cod. Take a look on the left-hand side. You can see the freshwater lens and what that means. And one of the things to keep in mind is as sea level is rising, and it is rising, it's actually going to push that freshwater lens up. So people on lakes and ponds are actually going to see their water rise as well. Streams are going to become more productive over time, which is good news and bad news, really, in terms of what that may mean for water conditions and nutrient overload here on the Cape. So here's your Title V septic system. Pretty much everybody on the phone will have, and on the line here, will have one of these systems, unless you're connected to the system in Hyannis or elsewhere. And this is really just meant to get waste away from your house. It doesn't, in fact, solve more than that. And it doesn't do anything for nitrogen. It doesn't solve the nitrogen problem. It does remove a little bit, but it doesn't remove very much nitrogen, unfortunately. So the 2 battles that we're really trying to fight here are new alternative septic system technology and a timeline to fix this problem. Septic system changes, that's a longer term. It's a source reduction. It's critical. It's the only thing that's going to solve this in the end. But there are things we can do in the near term. We're going to talk about that in a minute too. We have looked at other technologies. Some people on the line have composting toilets, a great technology, but unfortunately there's been a very low adoption rate here on Cape Cod. It's complicated, and we looked at that and realized from talking to the experts, it's going to be really hard to transition to that kind of technology. And so that really brought us around to looking at other technologies and working with our partners at the Massachusetts Alternative Septic System Test Center. And that group, one of only 2 sites in the United States that looks at alternative septic systems, introduced us to a system called the Nitro Wastewater Treatment System, a tank supplement. We're going to have a video on this in a second. It'll be good to illustrate it. But all this really is a tank that fits in between your existing Title V system, your septic tank. The flow then goes into 2 chambers of a concrete tank, aeration chamber, and a denitrification chamber, and then the treated effluent, where you've achieved sometimes 90–95% reduction in nitrogen, is where it then flows into a leaching pit, leaching field. At that point, you're performing, we believe, and this is the work we're going to do, at levels that are equal to, maybe superior to, most of the municipal treatment systems here on the Cape. So with that, let's look at a little video and we'll learn a little bit more about this system. So the waters in Cape Cod, whether it's freshwater or saltwater, are really most troubled by nitrogen. Nitrogen comes from us. It comes from our septic system. So 85+% of the problem here on Cape Cod comes from Title V systems that really don't remove very much nitrogen, if any. Nitrogen comes from our urine. Nitrogen is the key component that when it reaches water, it turns into fertilizer. It's the same fertilizer you put on your lawn. And so what's exciting about John's really simple system, it works alongside a Title V system, easy installation, and it ends up turning the nitrogen from a liquid into a gas. John, tell us a little bit about this system.
Glad to, Z. The system is a supplement to a conventional Title V. What a conventional Title V is a septic tank and a leach field. You have the wastewater going into the septic tank and then to the leach field and then to the subsurface. What a nitro wastewater treatment system is a tank that is inserted between the septic tank and the leach field. And this tank is engineered and installed in a way that it flows from the septic tank through the nitro tank to the leach field. And within the nitro tank, we can get 90–95% reduction of total nitrogen, along with significant degradation of organics and other materials that are present in the wastewater, so that coming out of the nitro tank is a very clean effluent, low in nitrogen, that will then extend the life of your leaching pit or leaching field as well. The design focus has been keep it as simple as possible, and that's simplicity of fabrication, simplicity of installation, and most importantly, from my perspective, simplicity of operation, because homeowners don't want to have to deal with a treatment system in their backyard. So this treatment system will act not totally maintenance free, but very close to it.
And then this is exciting. What we've got is a system that actually turns this nitrogen into gas. The gas goes out the roof vent, just like the roof vent you have now. It's harmless. We're breathing nitrogen right now. 78% of the atmosphere is nitrogen. So this system is simple, exciting, and it's a game changer. Okay. Well, so why are we excited about this system? So this is hopefully the first of more than one system that we're going to see that's going to have the ability to perform at a very high level. In fact, George Hoyfelder, who was at the Massachusetts Alternative Septic System Test Center, and Brian Baumgartel have designed and developed a system called a layer cake system that's very exciting, relatively low cost. It's all good. We're hoping to try systems like that out as well. This system has already moved through the permitting process with the Mass Department of Environmental Protection, and now is at a stage which is called provisional permitting. So an additional 50 of these systems can be put in the ground. Once they're in the ground and monitored for a period of time, up to 3 years, we then will see general approval. So this is the only system that's moved this far through the permitting process to get here. And it's not just that it's moved through that process, and that the permits are almost 50%, 40% better than any existing systems that have currently been permitted. But what's particularly exciting to me is that it's got characteristics that are particularly interesting. So it's modular. It'll fit into an existing Title V system, as John just talked about. It's relatively low cost. So we think as we start to roll these out at scale, you'll be looking at between $15,000 and $30,000, depending on whether you're putting in a full new system, so an existing Title V plus this addition, or whether you're adding on to your existing Title V system and just adding a separate tank. Critical here is that it's really gravity operation that occurs. And so that means that in the absence of power, you still have essentially a Title V plus system. You don't have to stop taking showers, using your facilities. You don't have to stop doing any of that. And let's face it, here on Cape Cod, we know at some point that's going to be a major issue. Loss of power is just going to happen. The only working part here is an air pump taking about the power of a typical light bulb these days. And that's it. And that's really all you need. We've also got real-time monitoring here. So we're going to be able to look carefully at what we call OM&M, operations, maintenance, and monitoring. Monitoring is going to be something going on for a long time. Long-lived, some people have asked, and I think it's a good question, how long are the wood chips going to last? Well, you know, the work that's been done so far indicates it's probably decades. So we think that these systems may in fact outlive your current Title V system. And in the end, you may have to replace wood chips. Let's face it, wood chips are not expensive. We could go in and just like you have your septic system, a drain periodically, your septic tank, you could do that, take care of the wood chips, put new wood chips back in and move ahead. All that's really, really exciting. But you know, the bottom line is, how do we figure out what that's going to mean to the environment? What's that going to mean to Cape Cod? How are we going to look at the waters of the Cape and see a change over time? We look at it as a generational change. I should note that there are commercial size operations like this as well. So this is a larger system, same company called Clean 2 developed. So this is actually a large version of the one you just saw in the video that's at the College Light Opera Company in Falmouth. And only tongue-in-cheek, we're seeing dramatic results. 86 average percent reduction in nitrogen, median reduction of 90. We think over time that John Smith and the scientists at Clean 2 are going to be able to achieve really startling levels of reduction of nitrogen. But we're looking not just at nitrogen, we're looking at other issues as well, whether it's phosphorus or contaminants of emerging concern. These are all going to be studied. And so working with our partners at the US EPA, at USGS, at the Nature Conservancy and elsewhere, we started to look at a program to figure out how are we going to understand all these systems as they're working together, potentially in one place in concert? How do we figure that out? So working with the team, we started to look at one particular area, Schubel Pond. Schubel Pond, we're going to look at a couple of locust maps and you'll see exactly where it is. 56-acre pond, about 56 feet deep at the deepest. A lot of groundwater coming in. So from upper left, moving toward lower right is where that groundwater comes into. And so you're seeing a constantly charged area. And this pond has been troubled. Right now, we've already got cyanobacteria warnings going on at this pond. So working with the scientists, we looked at it and realized that we've got modeling for groundwater. That's what this map shows. And this will give you the locust map. So on the star, you can see where it is relative to 3 bays and the town of Barnstable and Cape Cod overall. We've already put in one monitoring well, and that was what led us to this area to look at it, to understand that we've got high levels of nitrogen already here. We know we can monitor this area. In July, we're going to put in a network of wells. That network of wells, I'm not going to go to that video yet, sorry. That network of wells that's going to be put in here is going to give us more information about the groundwater so we can build out a network. And that network is going to tell us more information about this critical pond. And with that, we are going to go over to another video and you'll learn a little bit more about Schubel Pond and what the conditions are.
beautiful Shubal Pond in Marston's Mills. It's a gorgeous day, and I'm so fortunate to have joining me today Karen Melkus Benjamin from the town of Barnstable. So Karen, I know you're extremely busy, so it's such an honor to have some time to talk with you today. So Karen, can you tell me a little bit what you do with the town of Barnstable to help us with water quality?
Well, my focus is on all kinds of water quality, both marine and freshwater, but right now, because we're at Shubals, I would tell you a little bit about that. And what I've been doing is a new cyanobacteria monitoring protocol. So that looks at why we're seeing those strange blooms in the summer.
Okay, so cyanobacteria, can you tell us a little bit about what that means?
Yeah, cyanobacteria is an ancient organism. It actually is a bacteria. They used to think it was an algae, so some people call it blue-green algae, but now we've come to understand that it actually is more a bacteria that photosynthesizes, which means it takes the sun's energy and makes food from it. We're definitely seeing a lot more of these blooms, the cyanobacteria blooms that make toxins too. So, and also in the marine waters, there's more bacteria. There's all sorts of things showing that our impact on the water has been serious, and particularly from the 60s, 70s, and our build out. So yeah, cyanobacteria is an indicator that something's out of balance.
Okay.
We are contributing a lot of nutrients and all sorts of emergent contaminants to our water, both through our septics when we flush, and also over pavements and through our lawns, and just by all the things we do. So people are contributing and increasing the food supply, really, which is the nutrients and some of these alternative contaminants. Everything we do that we put on the land, we're in a sole source aquifer, so everything on the land goes into our aquifer and ends up either in a pond or in the estuaries, but also it can go across the surface. Like you said, stormwater or fertilizers can go right into a freshwater body and pollute it. Lately, particularly in the years that we've had heavy spring rains, like 2019, we seem to get a big input of those nutrients from the storm runoff that kick off these blooms in the pond. And last year, 2019, was horrible. Shubals was closed pretty much the whole summer and through the fall. And it's closed because the cyanobacteria, as it decays, produces toxins. It doesn't infect you like a bacteria from wastewater. It actually, as it dies, produces a poison, a toxin. So I keep track so people know when it's safe for their pets to go in the water, their children and themselves. There's a tiered sort of posting thing. But this year I don't know what's going to happen, and I'm monitoring. I start in May and I go through, and so I want people to be aware of the signs and keep track and stay healthy. But what they can do too is really important in their own homes and lives to reduce the nutrients that are sort of stimulating these blooms.
Karen, I want to thank you again for your time today. You know that we've got a huge project here at Shubal, so our partnership with you and the town is so important, and thanks for coming out today.
Well, thank you so much. These kind of innovative projects are huge and will be the future for saving our ponds and the water quality, so I'm really happy to be your partner.
Great.
Thank you.
We can't do this alone. We haven't been doing it alone. We have a lot of partners that are really critical. And, you know, the thing to understand about Shubal Pond is we worked with the scientists. We actually looked at 4 different locations around the watershed to understand where could we put in a test to understand what a collection of these systems would mean in the water and for the groundwater. And that's critical because averaging is the key. So a municipal treatment plant obviously collects wastewater from all sorts of households, all different households, and we know what happens. We know the averages. We collect things, and we do the math. So here, nobody had really done the math to understand how that might work, and so that's why we're putting in 20 to 30 systems in this particular area, and we're going to monitor the groundwater while we do it. So we're going to get all sorts of different constituents as part of this. It's great. Our key partners here are people that live in the neighborhood, the Shubal Pond neighborhood, and so we're going to get an older couple like myself and my wife, Susan. We're going to get a family of 5 or 6. We're going to get conditions in this area, we believe, of like 13 house painters that are in here seasonally. And it's that collection, and that changes all the time. And everybody intuitively probably knows the average 3-bedroom house on Cape Cod changes hands every 7 years. So we're constantly changing. And so this kind of work to understand the averages is absolutely critical. And so that's why it's been key to work with the partners that we have to understand exactly how we're going to move ahead. We're going to talk about some of these partnerships and what they mean and what we're doing. So the first one is with the US EPA. It's called the Office of Research and Development, and they work closely with the US Geological Survey. So these agencies, really 2 of, I think, the government's finest agencies, filled with dedicated dedicated individuals, very well educated, understand more about water conditions around the country than anybody. And they've been the ones who have been drilling wells. So they came in to this site. You can see a demonstration of the kind of well that was drilled, and that well and the wells that we're going to add. And you can see on this map, this is also a zoom in of the Lake Shores neighborhood, the Sand Shores community of Shubal Pond. And you can see numbered areas there. There's one black dot. We already have one well there. We're going to put another 9 wells in. EPA and USGS will put those in, along with, I want to say, Region 1. We're working very closely with Region 1, and Region 1 has been critical in this effort and helping us move forward on it, finance it. It's critical. The green lines actually are the model of what groundwater we believe is doing. And the drilling wells that we'll put in, water table wells, will let us identify exactly what the water is doing. And that's what's critical and interesting about this area is we've gated it. If you think of this area, it's up by the grass strip airport as you leave to go to exit 5 around here. There's a golf course. There are the Indian ponds further to the west. But that means we can identify using isotopes exactly where the groundwater is coming from. And that's going to be critical to do the experiment that we're going to do so we can look at how's it going to work when we build out thousands and thousands of these systems. There's about 160,000 households on Cape Cod. Mass DEP estimates that only about 40,000 households ultimately will get municipal treatment. That leaves over 100,000 homes. And if you start to think about it and think not just about the currently mandated stuff that Chris Kilian will talk about for nitrogen, but about phosphorus, about contaminants of emerging concern, about our aquifer. We believe that all homes on Cape Cod ultimately will need some kind of treatment. We live on a sandbar over a single source aquifer. It's critical. We have to get this kind of protection going forward. The wells will come down, and you can see in this illustration, in this cartoon, we'll be able to pick up and identify the groundwater flow so we can look at and understand exactly what that's going to mean as it moves through the ground. We're expecting to see major changes, and we think that those major changes are going to be critical. One of the things that's going to happen, if you think about your cell phone, when I think about these systems, it's distributed technology. We're not now taking wastewater from all the way from one part of town and shipping it all the way to Hyannis. A gallon of water weighs about 8 pounds. It's very expensive to move wastewater around. And then you're letting that water go into one location, which creates concerning plumes. Chris is going to talk a little bit about those concerning plumes. Here, in this case, we're going to put the water very close, the wastewater, just about back to where we took the water from. So we think there's a good balance and a good opportunity there. We're going to put in weather stations around the Shubal Pond area so we understand exactly what's going on in terms of rainfall. We've got these critical rainfall issues. It's critical to understand the weather patterns so we know what's going on in the groundwater. The way the water moves into a pond like Shubal is fascinating. It actually moves up as the groundwater approaches Shubal Pond 50 feet deep. It doesn't go directly into the side. It actually rises up and goes in one side. And then it goes and flows over and out the pond on the other side, just like you'd be spilling a glass of water. And so here we have scientists from the U.S. Geological Survey putting in push point sensors where they actually take the water, pump it out, and look at what's going on in the groundwater so we can identify all the conditions within this pond. We're going to understand more about this pond than almost any other pond anywhere. And that's going to let us understand more about what the critical changes mean for putting in these innovative alternative septic systems in this area. A lot of people will say, well, isn't the problem in ponds phosphorus? And from everything we understand, yes, that's one of the problems. And we think that this system and others will develop ways to reduce nitrogen. But it also seems to be the balance of nitrogen and phosphorus that's critical for the health of ponds. But we need to understand more about this to move forward. Our biggest partner in this effort, of course, is the community, and that's really why we're here. The people in the community they're passionate about their ponds. Anybody who's met people that live on ponds here on Cape Cod knows that they are just absolutely so invested in their pond and their conditions, you just can't believe it. So there's actually 3 times as many people that live on ponds on Cape Cod as the number of people who live on salt water. So keep that in mind as we move forward. With that, I want to switch over to the fact that we're not just working on source reduction, we're also working on another innovative approach, which is restoring a cranberry bog. Take a look at this map. And what this map shows is some rivers that are in and around the town of Barnstable. And it's interesting to note that rivers really deliver an enormous amount of the water load from the groundwater. The groundwater is moved into the streams. That goes into the rivers. They're really just big streams. And that flows very quickly into troubled water bodies. So here you have two of them. Pompanesett Bay on the left, that's the worst, most troubled by nutrient overload area. And I know we've got some people on the line here very concerned about that area. In the middle, we have the Marston's Mills River starting at Mystic Lake. And so think of these as really railroads that deliver nutrients very quickly into areas of our estuaries, overloaded areas that continue to get overloaded continually. So we're trying to figure out, how do we treat that? How do we move ahead with that? So this system is unique because the cranberry bogs are actually at the headwaters of the river. So think of it as a collection system. We're not worried about the cranberry production itself, but this collection system, which used to be wetlands back in the day. And we actually think it's fascinating that this area, which probably was one of the economic saviors of Cape Cod, cranberry bog business, very, very important historically, that business has changed dramatically. The business has now moved to industrial farming, just like a lot of other production, mainly in Wisconsin and other areas. These businesses are going to have trouble here on Cape Cod, but it could be that these could help us change dramatically the water conditions, and quickly. And that's one of the key things. So groundwater moves at between 1 and 4 feet a day on Cape Cod, so relatively quickly. But when you look at the river system, we're delivering 40% of the excess load of nutrients from this cranberry bog area into the Prince Cove area in just 4 hours. So pretty darn quickly. And so this is a historical map. You can see what the wetland conditions used to be. The same Indian ponds are shown here on the right. And we can see from this map exactly what the conditions used to be. And so we're going to work with our scientists, with our partners, to move back toward a restoration. We believe that restoration could reduce massive amounts of nutrients, and that's why we're looking at doing this. In addition, it could be a wonderful ecological success story. This just shows you that connection. The cranberry bogs are in the hash mark, red and blue, and then lower right, you've got the Prince Cove, Warren Cove area, and you can see where that river system is and how quickly it would move into that area. One of the things we're going to do is look at, are there good ways we can restore cranberry bogs? So we're doing an experiment that's identified there where we're going to put what's called a permeable reactive barrier. Same technology using wood chips. And wood chips, by the way, are being used around the Mississippi River in agricultural areas to do the same work. The wood chips can allow a lot of bacteria that respirate nitrogen to exist and knock down that nitrogen load, which in the water is very harmful, but in the air is harmless, as we said. So 40% of that excess load is the bog math, gets there in 4 hours versus 4 decades for the groundwater, which is also so critical for source reduction, municipal treatment, and the cost may be dramatically lower. Municipal treatment at $1,000 a kilogram, maybe it's $100 here. How does a restoration look? You look at that picture and it's like scary. What a mud pit. This is unbelievable. But when you start the process, you see the changes, the stream is still there. This is another restoration project just off Cape called Tidmarsh. Here's what it looks like after a year. And we'll have a little video talking about how that process works. And then we're going to go right over to Chris Kilian, and we'll have Q&A at the end. So thanks for listening, and I'll be back in just a second.
Barnstable Clean Water Coalition is working on several approaches to intercept and treat this toxic water, and retired cranberry bogs are ideal locations that could offer just that opportunity. These bog areas were once natural wetland systems which naturally controlled nitrogen and other nutrients in surrounding bodies of water. In late December of 2019, the Barnstable Clean Water Coalition, in partnership with the EPA and the Nature Conservancy, hosted its first annual Restoration Project workshop. Its goal was to align a private cranberry bog landowner with leading environmental scientists, researchers, town officials, and policymakers to transform the Marston's Mills cranberry bog back into wetlands, creating a natural nitrogen reduction system. The choice made to use the Marston's Mills cranberry bog as a model test area was very much intentional, as its location serves as a pass-through to 3 major bodies of water, all which are currently impaired with high levels of nutrients.
Because these bogs exist in low spots, they're former wetlands, they're right along rivers, there's an opportunity to modify or restore current cranberry bogs into natural wetlands that would have a much greater effectiveness at removing nitrogen from incoming groundwater.
Can we put a pond, a terminal pond in this cranberry bog system to operate again as a nitrogen reduction system? Can we modify the streams in a way to alter the carbon-nitrogen cycle to enhance the removal of nitrogen as the water just passively flows across the surface?
As it stands, the town of Barnstable has a sewer expansion plan which is approaching $1,000 per kilogram to remove nutrients from waterways and ponds.
Here we have a chance to use a natural system, change the cranberry bogs potentially back to the wetlands that they were historically, and have nature do the work.
If we can show that restored wetlands on retiring cranberry farms removes nitrogen that benefits the communities, in my view, maybe that helps us identify more resources to steer retiring farms and willing landowners down this path.
Wetland reconstruction and engineering is one of the many projects in store for the future that could help reduce these projected costs.
Okay, so we're going to go over, one of the things you could learn from this was how important our partners are. And so one of our important partners is who you're going to hear from now, and Mike's going to introduce Chris Kilian. I want to take one segue. All this work takes a tremendous amount of money. To the extent that you can make a donation, you can support our work, you believe in our work, you can spread the word. Please help us. It's a tough year. It's a tough year for everybody, but we need to solve this for our kids, for our kids' kids. We all love Cape Cod. That's why we're here. And Chris loves it too. He comes down here and fishes all the time. And I'm going to let Mike introduce Chris.
Thank you, Z. Great, what a bunch of great work you've been doing. And I do want to reiterate, any help you can give us financially, or volunteering, participating in our meetings is welcome and needed. Before I introduce Chris, I just wanted to ask everyone here if anyone really remembers how polluted Boston Harbor was. I do. I grew up in Quincy. I used to fish off of Castle Island. I used to go to Wollaston Beach. If you might remember, Boston Harbor was so polluted that it actually affected a presidential election when George Bush kind of beat Governor Dukakis over the head with the Boston Harbor pollution problems. It was that important. In 1983, CLF led a lawsuit, the municipal water systems and the state DEP, about the status of Boston Harbor. And back then, everybody said the same thing they're saying to us today. It's not necessary, it's impossible to fix, it's too expensive. And 30 years later, what you hear is, can't live without it, don't remember it was any place like it was today, we should have done this sooner. I'll give you my own anecdotal story. I was in Charlestown Monday picking up a boat for delivery here to Cape Cod. And as I steamed out of the harbor, there were stripers boiling in my wake. The air smelled good. There were birds busting on bait, and there were people catching lobster traps in Boston Harbor. And we did it went from where it was the most polluted it's ever been and to cleanest it's been in my lifetime. We have CLF to thank for that. So with that, I'd like to introduce Chris Kilian. He's the Vice President of Strategic Litigation at the CLF. He lives with his wife and family in Vermont, and he is championing with us the cause for clean water on Cape Cod. Thank you, Chris. Do I need to hit anything?
I'll come in. When Chris is done, we'll go over to Q&A. So we'll switch over, Chris, to you, and you'll be driving the bus.
Okay, thank you to Barnstable Clean Water Coalition and to Z and Mike. And I just want to acknowledge how inspiring the Z's presentation was for me. It's so important to focus on the positive aspects and the solutions for the problems that we see in the environment. And that's one of the things that gives me hope for Cape Cod, for the bays on Cape Cod, is that in general, the story on Cape Cod is about folks acknowledging the problem and figuring out solutions, as there are ongoing debates about time frame and cost, but in general, at least we're acknowledging the solution or the problem and the need for solutions, which is not necessarily the case throughout the country. And Z asked me if I would join the meeting today. Again, thank you so much for including Conservation Law Foundation, because we've been working in partnership with BCWC and others on the Cape for years now. Folks might be aware that Conservation Law Foundation filed a lawsuit a few years ago against US EPA that resulted in an update of the area-wide waste management plan under the Clean Water Act. But another component of that lawsuit, and something that we've been focusing on through litigation and advocacy on Cape Cod for a long time, is an unfortunate loophole that has been present in the Clean Water Act. And it basically stems from the fact that the Clean Water Act requires permits and requires regulation for sources of pollution that can be categorized as a point source, and does not require the same level of regulation and oversight for sources that are categorized as non-point sources. So in the simplest form, a point source is a pipe or other human-made infrastructure that carries pollutants from an activity and puts it in a waterway. Well, the big issue and the loophole that has arisen is, what about scenarios where those pollutants are placed into the ground and travel through groundwater, and through that means ultimately reaches a waterway, which is what we believe is the case on Cape Cod. And this issue has been of such great importance that over the course of the past 5 or 6 years, there has been litigation throughout the country focused on this issue, where there are different sources of pollutants that are discharged into groundwater, but ultimately reach surface waters. And this past year, one of those cases reached the US Supreme Court. And that is actually what Z asked me to talk about, because this case has great implications for places like Cape Cod, where pollutants travel through groundwater. So I'm going to share a short presentation with you all now. And talk about the case. So the case was the county of Maui, Hawaii versus Hawaii Wildlife Fund, and that was the caption of the case at the U.S. Supreme Court. When the case started, you won't be surprised to hear that the caption was reversed. It was actually Hawaii Wildlife Fund versus the county of Maui. So a little bit of background on this case that went to the Supreme Court and was decided. Since the 1980s, the wastewater treatment facility that was at issue had been discharging treated sewage in a manner that ultimately reached the ocean. It was 4 million gallons per day, and the treated effluent was sent via injection wells into the porous lava bedrock of the area. And it ultimately showed up in the ocean, not in a bay, but out in the open ocean off of a beach. And based on that distinction, US EPA, state regulators, and the municipality had been calling this source of pollutants a non-point source, and thereby avoiding the permitting requirements of the Clean Water Act. Studies tracing the flow from the facility showed that the discharge showed up after traveling about a half mile in the groundwater in a relatively defined area. And so in 2012, a nonprofit organization like CLF called Earth Justice sued the county and argued that they were discharging pollutants without a Clean Water Act permit. EPA, initially in the case, took the position that perhaps the discharge required a permit. And that was the position of US EPA, both at the district court level, the trial court level, where Earth Justice and the local groups prevailed. The district and federal district court in Hawaii found that a permit was required, that this fell within the definition of point source under the Clean Water Act. That was appealed to the Ninth Circuit Court of Appeals after the decision of the district court, and the Ninth Circuit Court of Appeals also upheld the requirement to obtain a permit. EPA maintained the same position. But when the case got to the Supreme Court, the current administration took the position that not only was this did this scenario and similar scenarios not fall within the definition of a point source, but that in fact, if pollutants are discharged into the groundwater and then travel through that groundwater into a surface water, that that source of pollutants and that type of pollutant discharge is categorically excluded from the Clean Water Act and not within the scope of EPA's permitting program under the Clean Water Act. So the case was argued to the U.S. Supreme Court last fall. The justices were very active in questioning all sides in the case and were very pointed in their questioning of US EPA. And again, US EPA was in the case basically as a third party. The primary lawsuit was against the nonprofit NGOs, the local organizations, and Earth Justice in Maui, but EPA was weighing in. And the court issued its opinion this past spring, just over a month ago. And in a 6-3 opinion that included the 4 liberal justices, Chief Justice Roberts and Justice Kavanaugh in the majority, the court upheld the requirement that a permit could be required for this facility and rejected US EPA's, this administration's interpretation of the Clean Water Act, and wrote that to follow EPA's reading would open a loophole allowing easy evasion of the statutory provision's basic purposes. Such an interpretation is neither persuasive nor reasonable. Instead, the court ruled that the Clean Water Act requires a permit when there is a direct discharge from a point source into a navigable water, or when there is a functional equivalent of a direct discharge. And then the court laid out 7, what it referred to as non-exhaustive factors to consider when looking at this question of functional equivalency. The first one is the transit time. How long does it take for the pollutants to get from the discharge location to the surface waters? The distance traveled, the nature of the material through which the pollutant travels, the extent to which the pollutant is diluted or chemically changed as it travels, the amount of the pollutant entering the navigable waters relative to the amount of pollutant that leaves the point source, the manner by or area in which the pollutant enters the navigable waters, and the 7 is the degree to which the pollution at that point has maintained its specific identity. So there are 7 factors. I would argue that many of them are met on Cape Cod with regard to discharges from septic systems, wastewater treatment facilities, and from stormwater sources discharging nitrogen and phosphorus into the bays and into the ponds. Not the least of which are the nature of the material through which the pollutant travels, the soils and soil types on the Cape, the porosity of them is well documented, the extent to which the pollutant is diluted or chemically changed as it travels. There's very little reduction in nitrogen as it flows from sources to the bays. And so our view is that this opinion, which was somewhat surprising, people were very concerned about the composition of this court, has great impact and implications for Cape Cod and any other area that has wastewater discharges that look like the discharges on Cape Cod. There are a few, I guess I would like to focus on a couple of things just to make that point. One is, for example, looking at the total maximum daily loads for the Cape, and specifically the Lewis Bay TMDL, just using that as an example. The state and EPA have written in all of those TMDLs that wastewater effluents from septic systems and wastewater treatment facilities discharge to the ground, enter the groundwater system, and enter the surface water bodies. In the sandy soils of Cape Cod, effluent that has entered the groundwater travels toward the coastal waters at an average rate of 1 foot per day. Similarly, they wrote nitrogen transfer through direct groundwater discharges to estuary waters is based upon studies indicating negligible attenuation and dilution, i.e. 100% of load enters the bay. Those are the findings of the state and EPA in the TMDLs. And in the Lewis Bay, I was reading from the Lewis Bay TMDL there, but that language shows up in all of the TMDLs for nitrogen. Again, focusing on Lewis Bay, I wanted to just sort of highlight that the Barnstable Water Pollution Control Facility in Hyannis discharges over 1.4 million gallons per day into Lewis Bay. That nitrogen load is well documented. It travels through the ground in a very well documented fashion. Goes into different water bodies, but nearly half of the nitrogen load in Stewart Creek is from that facility. I would also point out that US EPA and the state, in writing the TMDLs, implemented a rule of thumb, but it was used for purposes of all of the modeling and ultimate regulatory requirements to date, that only stormwater discharge sources within 200 feet of a surface water body would be included as non-point sources in the TMDLs. I would note that none of the wastewater treatment facilities were considered to be point sources. No septic systems were considered to be point sources. None of the current water pollution control facilities on the Cape have Clean Water Act permits. And so the case has significant implications. In addition to raising this issue in our lawsuit against EPA several years ago, we've also brought, CLF has brought 2 lawsuits over the last several years on the Cape, one against Witchmere Resort and one against the Wequassett Resort and Golf Club. Both of them were founded on this notion that a Clean Water Act permit is required. that these were in fact point sources. Both of those cases, one of them is fully settled. The Wauquasit case is fully settled with significant upgrade in the nitrogen controls at that resort and significant investment and additional reductions from other sources in the watershed. And we have a proposed settlement in the Witchmere case that actually we reached after the Maui case was decided, because that case was actually pending on many of these same issues in the federal courts in Boston. And once the Maui case came out, it was clear that a settlement not only could, but should be reached. And we now have a proposed settlement that would require significant upgrades there and additional investments in other reductions within the watershed at Witchmere Harbor. I also, just in closing, wanted to mention that this case, from our perspective, this U.S. Supreme Court opinion has major implications in indicating that, from our perspective, a lot of sources on Cape Cod are discharging without required Clean Water Act regulation right now. And that opens the door for organizations like mine to actually seek to enforce the law, but also should trigger additional oversight from US EPA. It also, the opinion was also critical in rejecting the Trump administration's very narrow interpretation of the Clean Water Act that cannot be relied on as a basis for avoiding permits. But more broadly, what's the point? The point is that the Clean Water Act is the nation's preeminent clean water law. And with a Clean Water Act permit come conditions and restrictions that are targeted at surface water rather than groundwater alone. And those conditions are enforceable not only by governmental entities, but also by citizens of the United States through the citizen suit provision. So there are increased opportunities for accountability and enforcement of both the requirement to be regulated, but also what that regulation looks like. And the Clean Water Act nationally has been the primary driver for clean water. States do important work as well, as do municipalities, but really it has been the Clean Water Act that has driven the most dramatic improvements in Clean Water Act since the early 1970s. And it's critically important that that law be applied and implemented here. We intend to focus on using this precedent and the Clean Water Act to continue to drive forward on implementation of controls. Folks are talking about those controls. They're talking about what is needed, but we want to see on the ground implementation. We also think timeframes need to be accelerated dramatically. We can't wait 30, 40, 50 years, or even 20 years for implementation of appropriate controls. We acknowledge that the Clean Water Act alone won't do it, and we think there are serious problems with lack of enforcement and appropriate implementation of Title V at the state level, and we applaud the efforts of municipalities and others to move forward where they have, and clearly state and local requirements are needed. But the Maui case should have significant implications for Cape Cod, and we look forward to moving the advocacy forward to see that the full potential of the Clean Water Act and that case are realized on Cape Cod. With that, I'll wrap up and thank Z and Barnstable Clean Water Coalition for the amazing work that they're doing and for including us in this presentation.
Chris, thanks so much. Really terrific presentation and so important. You know, when we look at the problem, there's some questions, we're going to get some questions. We're hoping that municipalities, the local boards of health ultimately will move forward aggressively on this. And so there's a question, how could I get one of the systems that we illustrated, one of the nitro systems? Remember, there's right now the ability to have 50 additional permits. It's so critical to get these systems in the ground, to get the clock running so we can get them fully approved at the state level and expand these systems really all over the Cape. And our hope would be that if you're in an area that's nitrogen and nutrient sensitive, that you're not going to get municipal treatment, and that's all pretty well understood at this point, then any new system, any failed system, maybe any system within a certain distance of a water body would have a certain amount of time. Maybe any title change would be the catalyst, just like it is now in a property transaction. And we're working on the financing elements of this too. So we're working with a number of consultants and with the state to see if we can't have state revolving funds, which are available at very, very low interest rates for very, very lengthy periods of time, help step in and finance these alternatives and alternative septic systems that we think are so high performing. So somebody asked, how can I get one of these systems? One of the things to know is on the sign-in today was a application for a grant. We're willing to provide grants up to $10,000 for citizens to put these systems in, and we want to help. We're already helping in the Shubal Pond neighborhood, and we've committed over $350,000 of this organization's money. We're applying for a grant. The town is actually applying for the grant, a municipal vulnerability program grant of $1.2 million to accelerate the program in Shubal Pond. So critically important. I'll answer one other question that a gentleman named Rick asked, which is, well, how do we know the wood chips work? And the answer to that is that a group actually in Waterloo, Ontario, had been working with wood chips for 40, 50 years and really looked at wood chips just as another carbon source. So in any municipal plant, various catalysts are used, chemicals are used to create biologic activity. It's really all biological activity that breaks down waste products. And so in this case, the carbon source is wood chips. And we were fascinated a few years ago when we got involved. A group called the Marine Biological Labs based in Woods Hole has put in an experiment in the ground, really in the shore side in Wacoyet. You can go down there today. They did it 15 years ago. There's a trench with wood chips underground. It's about 100 feet long. It's about 10 feet deep. And you can dig down today. If the wood chips are in an anoxic environment, an environment where there's no oxygen, they last forever. So you can dig these wood chips out. They do periodically. You can't break them. It's just like a new wood chip that was just chipped. It's still providing a carbon source, and it's remarkable. If you look at this particular area, you can see algal blooms and algae problems stretching out into the water. And then you go to this area where the wood chip permeable reactive barrier is, and you can see it's kind of like the shoreline used to look at Cape Cod. So a remarkable difference. And really, restored wetlands do the same thing. So in this case, the plants are doing the work, and that's one of the things we're going to try to look at. So not just introducing some wood chip related stuff into this area, but we think ponds, as one of our speakers talked about, are very successful at allowing nitrogen biologically to gasify. So that's critically important. Chris, there's a question on the screen for you, and please ask some more questions. We have a few questions, but we're happy to entertain more. And the question is, will CLF be filing against these towns that do not have Clean Water Act permits?
Well, with the caveat that past performance is not an indicator of future activities, I would point to the fact that we've been very active on Cape Cod. We are taking a hard look post Maui at the factual circumstances around each of the municipal discharges, but many other sources as well. And we're committed to moving forward with advocacy targeted again at implementation of technologies and measures to reduce nitrogen in the near term, consistent with appropriate permits or court orders. So I can't answer absolutely yes, but suffice it to say we're spending a lot of effort to understand exactly what the facts are and how the law would apply.
Thank you very much, Chris. Everybody got to see a couple of the videos that we've produced. We're going to work hard, and one of the good things that's happened for us out of the whole COVID-19 experience was we learned that we really need to be better at communication. And so we're putting together, we're thinking of it as a library with books on the efforts that we're doing. So whether it's working in the cranberry bogs and that restoration project, or whether it's the innovative alternative septic system technology, we're building a library of video shorts, 2 to 3 minute videos. So we have people in the community who live near the pond talking about why they love their pond, or how do these systems work. We have our alternative septic system people talking about how does that system work, like you just saw with John Smith. We have somebody else who's on talking about what is a Title V system and how does it work. So we'll welcome your ideas on that. We're going to continue to build that library so people can go to the website, understand the problem, learn more about it, and then we're going to tag team with people like Chris so partners can get on and really start to answer questions, and people can go back and look into exactly what the answers are. Daycare facilities on Flint Street. So we are looking at places to put in larger systems and work with the scientists on that. And so the Opera Company in Falmouth was supported by the Buzzards Bay Coalition. They do great work in and around Buzzards Bay from the east to the west side. And so we're certainly going to look to encourage more of that, is what I would say. We don't have plans right now. Our plans are dedicated individual systems around Shubal Pond and individual systems elsewhere, but the collective monitoring will happen in and around Shubal Pond. Does nitro need to be completely gravity fed? Well, gravity is the best way. Then you don't have any pumps, you don't have any issues. The air pump doesn't move any of the liquid effluent around. It just allows everything to be treated as it moves through the system. So gravity is actually the best kind of system, and it's just like a Title V system. It's one of the things we try to do is figure out how can we have something that's really simple. Many of the other systems are what's called pressure dosed, which can be very successful, but you need to keep constant pressure on. And so the challenge there is if you don't have a backup power source after a couple of 2 or 3 days, you could have a problem with your wastewater backing up. And we think that's something that's really, really concerning. And so we want to make sure we can solve for that with whatever kind of systems we have going forward. Other than donating or putting in this system, are there other things we can do? Sure, you can contact us. We're looking for volunteers. We do water monitoring, both in freshwater and in saltwater. We do that weekly. We do it in dozens, literally dozens of locations. Usually we're also doing things like counting herring and looking at what's in the water and understanding more about that with our scientists. So talk to us about volunteering, and we need people to help spread the word. That's all really critical. Which of these IA systems is actually permitted by the town of Barnstable Health Department? Gary asked. So Gary, you know, there are a number that are out there that are permitted by the town of Barnstable, and we have a permit for the Clean 2 nitro system. And so you could actually go to the town of Barnstable and send me an email, and I'll send you to the link to a video presentation that we did before the Board of Health, where we had all of our partners discuss the Shubal project. And I'm very pleased to say the Board of Health was very, very constructive. And they said, you know, how can we help? What do you need? They get it. They understand the conditions and understand the seriousness, especially in the ponds. I would like to get more information about safe ways to fertilize lawns. We're working on that very question. I wish I could tell you that I had a lot of information on it. We're looking for volunteers to help us with that. So back to the question of what can I do to help us expand our reach into other areas. Stormwater is a problem. Fertilizer is a problem. And up in Vermont, where Chris is, they have really pretty strict regulations around fertilizer. And we have friends that come down from New Hampshire and Vermont to the Cape, and they go to local places, the local nurseries, and they say, I can't believe you can even sell that stuff here. We're not even allowed to have it here, let alone you've got stacks of it, and people are using fertilizer they shouldn't be using. So we're looking for innovative ways to educate We've worked with other communities like Martha's Vineyard, which is very good. So we're looking to put together a program like that. So the answer is stay tuned and help us put it together. We'd really love to get more information on how to do that. You know, one of the ideas actually was the golf course superintendents, golf course people. A lot of people think golf courses are bad citizens, but for the most part, they understand the science of growing lawns. Lawns actually remove 85% of nutrients, and in many cases, and many of the towns now are looking to put some of their treated effluent back into their golf course systems and use the golf courses to actually be supplemental treatment systems, because then they don't have to apply as much nitrogen and nutrients to get the lawns to grow. So we've talked about talking to the superintendents and seeing if we can't educate people about how that is. You know, there's 27,000 acres of turf on Cape Cod, not including the golf courses. An astounding number. You know, but maybe it doesn't have to be all bad. We've looked at ways to approach that and hopefully turn something into an opportunity. Yes, there are alternatives, and we want to promote choices other than lawns on the one hand. On the other hand, we know people love their lawns, so if we can figure out how to make it a win-win, make it more efficient, we're into making that happen. Any other questions before we wrap up? I think I've gotten most of them. I don't see anything else on the screen or in the room. Everybody's been great, patient, interested. We can't wait to get back to a world where we can share a cocktail with you, have a conversation with you, sit down one-on-one. We have put a tent and a big picnic table out in the backyard, and we're doing a lot of our work from there. And so we're happy to meet with anybody under those conditions that feel safe to do it. And we're out here working tirelessly to solve this problem here on the Cape. And we're hoping it helps solve the problem elsewhere. So thank you, Chris, and thanks everybody. And we'll sign off and have a good night and a great summer if we don't see you. Take care.